Now, to conclude this section about structs, there's one last important feature about structs that we should not skip. And it's related to this output user details function. This is a function that's really tightly coupled to the user struct. It wants a user struct pointer as a parameter, and then we access the different pieces of data stored in the user struct. So this function doesn't work without a user struct. And that's of course different from getUserData, for example. Despite the name, this is a fairly generic function. It fetches some input from a user, but that can be any kind of input, and it could be stored anywhere, not necessarily in a user struct. So that is a fine function, but output user details, since it is tightly coupled to this user struct, can actually be turned in a different kind of function that is supported by Go. And that is a so-called method. Methods are still regular functions, but functions that are tied, connected to a specific struct. For this, I'll cut it. It's technically not required, it could stay where it is, but I'll move it up to my struct definition so that we have both close to each other so that we can immediately see all the things that make up that struct. And that's important because this function will now soon also be part of that struct or be an important addition to this struct. We can connect it, officially connected to this struct by changing this syntax a little bit. We can add a so-called receiver argument, which is a piece of syntax we haven't seen up to this point. Between the func keyword and the function name, we can add another pair of parentheses, and in those parentheses we can now define a single parameter that will point to a struct to which we want to connect this function. We could name it user and give it the type user. So just as we add parameters here in the main parameter list, but now in this special receiver arguments list here. Now we have a name clash, hence I'll remove user here in that main parameter list, though I want to emphasize that we still could accept other parameters if that function would need them, in addition to the struct. We can also still return a value if that would be required. It's still a regular function from that perspective, but it has this special receiver argument here. And this receiver argument is a Go feature that connects this function to the struct of which type the receiver argument is. So the receiver argument user is of type user struct, so this struct, hence this function is now connected. We can now also just name it output details because we already have that clear connection to the user struct because of this receiver argument. So repeating that in the function name is possible but redundant. Now this function can stay the way it is. The function body doesn't have to change, it still works as it did before. But we now call this function differently. Instead of calling it just like this as we did it before, we now instead call it on an instance of our struct. So we can use new user, which holds a pointer to this struct, and thanks to that shortcut which I mentioned in the previous lecture, we can use the dot notation on that, but now not just to access the different fields like first name and last name, but also to access this output details method. It's now listed here in this auto suggestion menu because of that receiver argument. So it's really an official thing supported by Go. So now we just call that function with that dot notation directly on new user, on the pointer or the concrete value. Because of that shortcut mentioned in the previous lecture, both works. That's now how we call this function, which is tightly connected to that user struct because of that receiver argument. If we now save that code and we run this module, that still all works as it did before. It still works without issues because this is using this official method feature built into Go. And it's a great idea to turn functions that really only work with one specific struct into such methods, because you then have this clear coupling and you can use the dot notation to access that method on the struct for which you want to do something. So that is really a good feature which you should use whenever you have a function that is specific to a specific struct. Now in that method, I am using a user value at the moment, not a pointer. We can also expect a pointer instead by adding the asterisk here. Just as for the regular parameter list, both works and we have the same advantages and disadvantages. If we accept a pointer, we avoid unnecessary copying in the memory space, and therefore this is often the better choice. Of course, in cases where you want to create a copy, where you don't want to work on the original struct, you can instead also accept the value as we did it before. It again comes down to what your method does. Here, for just outputting some data, a pointer is definitely better because we avoid that extra copy which would serve no purpose at all here. Hence, I accept a pointer here. And that's now how we can add such a method. A really useful feature for connecting a function to a struct if that function only works with that struct anyways. And that's also what we saw before on createDate, which is of type time, which is a struct built into the time package by the Go team. If we would access, let's say down here, new user createDate dot to dive into that time struct, we see a bunch of functions, methods as we know now, that are connected to createDate. So here the Go team defined a bunch of methods for the date struct that work with that struct only. For example, to return the day of the month of a specific date snapshot. So here we see that method feature in action for the built-in struct. Here we see how we can build it for our own structs with help of that receiver argument. Now that's it for this course section. We learned about another key feature, structs. Structs are great for defining your own pieces of data in cases where the built-in data types are not enough, or more specifically, for cases where you want to group certain pieces of data together. And you can group any kinds of data. Here we have a bunch of strings and another struct grouped into our own struct. So such nested structs, structs inside structs, are also possible. And then the great thing about such structs is that we can create them by using that literal notation here. And we can then pass around and work with those data packages instead of having to use all those variables over and over again in different parts of our application. Now, when it comes to creating structs, as I mentioned, we use that literal notation where we set all our key value pairs using the key names defined in our struct blueprint and then assigning fitting values. Or if we keep the order, so the order defined here, we could even omit those key names. So here I actually added them even though it's technically not required because I do have the same order of values as I expect them in my blueprint. So both approaches are possible. Here in this example, we also see another convenience feature which we can add to our applications, a creation function for our structs. It's a regular function in the end, but it does one main thing. It creates a new instance of that struct. It runs that struct literal code, and it even does some additional initialization work. In this case, it's creating this timestamp. Having creation functions like this saves us the hassle of running all that initialization code here over and over again in different places of our app. Of course, in this demo app, we only have one place where we do that, but in bigger apps, it would be very common to have different places where this happens, and then having such a creation function is very convenient. By the way, here where we call new reader on the buff.io package, we in the end also use such a built-in creation function, because it turns out that the reader which we get here is also a struct built into Go. That's just a side note though. Now we can then use structs to create them and store data in them, and we can also add methods on them, like output details, which we added here. Thanks to this receiver argument, we can connect functions to structs so that those functions only work with those structs and are executed through the dot notation. And the dot notation is, in general, how we can dive into the data stored in structs. We can use it for calling methods, but also for diving into the different fields in case we need to work with that data, which is of course something we typically need to do at some point. Now, last but not least, it is worth mentioning those pointers again. Especially when working with structs, pointers can be important because without pointers, if we pass structs as a parameter to a function, for example, we always copy that entire struct. So we occupy extra space in memory, and we can save that by using a pointer. As a convenience feature, Go actually allows us to use the dot notation even on a pointer to save some extra time and avoid that longer form which we otherwise would have to use. We can avoid that because Go has this built-in convenience feature. And that's it for this introduction to structs. In the next course section, we're now going to practice working with them in a more realistic project, and then thereafter, we're going to dive even deeper into Go.